We'll continue working on our shipping shoes program. Right now we're going to explore the idea of having a constant value. It's like a variable, but it is really not a variable because it never changes. We've decided that for every 100 pairs of shoes you order, they're going to go into a crate. That is going to be a constant value throughout this program. So we'll type in const for constant. And then the identifier of this, traditionally in every programming language you're in, is all capital letters. Whenever you see something, an identifier in all capital letters in a programming language, you can assume it is a constant value that never changes, or a final value that never changes. This value deals with how many pairs of shoes are going to be in a crate. So I'll start this with an int since it's going to be an integer. And then since everything's uppercase, we'll separate the words with underscores. So int shoes per crate. I forgot to put an underscore in there. I'll have to catch that in a moment. And we'll declare this as an integer. And we must set it equal to a value right now. We'll set it equal to 100. We can then go down in our code and take out the 100s and put in this constant value int shoes per crate, which right now happens to be 100. When we run the program, it will look just the same as it did before to anyone using it. But should things change, the boss comes in and says we're going to use a different shipping company, and now there's 20 shoes that will go into a crate, and the rest will go into boxes. Well, if we have lots and lots of code, it would be very difficult to use find and replace to find where all those 100s are. But if we've used this constant, we can simply go up to the one place where we declare the constant and change its value. So we'll change it to 20. And now the program runs with every 20 pairs of shoes going into crates. And those would be the correct answers. The next thing we're going to check out is when users type in things or don't type in anything at all that don't work. We're expecting numeric data when we ask customers how many pairs of shoes they would like to have shipped to them. But what if they type in a bunch of words? I like shoes. Well, our program doesn't like that. That's a string of characters, and we're expecting a number in this stage right here where we're trying to convert an integer to a string. So that causes an exception. Whenever we have an issue in a program like this, we call it throwing an exception, and this is an invalid cast exception. Don't really worry about the type of exception right now. Just understand that the word exception means that we've got problems. The data does not match up the way we need it to. However, we all know people who don't follow directions, don't want to follow directions, accidentally don't follow directions. It's very possible when users run our program, they will not type in numeric data, and we've got to be able to take care of it. We can do that by using try catch. I'll type the word try and hit enter, and notice that the Visual Basic IDE has given us the catch and end try. Catch EX is exception and end try. You don't need to worry about what all those things mean other than the try is the start of the try, the catch is where things are going to go when an exception happens or an error, and end try is the end of this whole block of code. Well, all of this stuff is going to go inside of the try because if there's a problem, we don't want the rest of the code to execute. So we're going to try to see if we can get valid data out of the text box at this point right here. If it works, we'll keep going through the try and successfully do the math and display the results. If this doesn't work, if anywhere along the way we throw an exception because we've got some issue, we'll have a message box display telling the users that they need to enter numeric data. Now again, this won't correct math mistakes, but it's going to correct, for instance, in this case, a data mismatch where we're expecting a number and we have a string involved. If we had one label, we might consider putting that error message in the label. That's okay as well. With the two labels, one for crates and one for boxes, I decided to just go with one message box. So now if we type in a bunch of nothing that doesn't mean anything, we get a message box to please enter a number. However, I've got to actually go back into that text box to change the value. We know the next logical thing is to go to where the problem is. So in a moment, we're going to actually send the focus to the text box. We're really helping the users out here. Number one, we're giving them a message to tell them there's been an error. And number two, we're going to put the cursor right where the error is to allow them an easy chance to fix it. So we'll get the text box in here. txt shoes dot focus, and that will put the focus into that text box if there's an exception thrown, likely because of a data mismatch. And there it is. The cursor's right back inside the text box. So now we can actually type in a number and get the answer we need. That's try, catch. Type the word try, hit enter, and Visual Basic should give you a block. We'll get some more practice with that in the future.